Hi there. I want to do this problem again, this last problem from the last video. I want to do it again and show you how to find probabilities on StatKey, okay? I like to start with Rossmann chance because it gives us really concretely, it gives us the 325 out of 2,000, for example, in the last problem, and shows that, it's dividing that, and that's how we get our probability. StatKey is just a little bit more abstract, but it's essentially doing the same thing, okay? So we're going to start moving over to StatKey. The other thing I love about Rossmann chance is it has those sliders, which we were using in the last video as well. However, we're going to be moving over to StatKey and using that more often, so I want to show you how to find probabilities there as well. Okay, so I'm going to write Rossmann chance over on the side here. That's just the name of that that set of applets. And then StatKey, I'm just going to make a line and write StatKey over here. Okay, so let's set up, we're going to do this simulation. So we have our population proportion of 0.37 for people in the US with type O positive blood, and we're going to simulate 2,000 random samples of 100 people. Okay, so we're doing a bunch of samples of size 100. Let's go ahead and go over to StatKey, and I've got sampling distribution for a proportion. I want to click on Edit Proportion. So this is our population proportion of 0.37. And then we get to choose samples of size n equals, I want to change that to 100 to match my question. Okay, and it's very similar to how we did the original baseball problem, right? But this is a proportion instead of a mean, okay? There are some data sets that you might be directed to in a question, or you can do edit proportion and put in any proportion, which is fantastic. Okay, so again, we can generate one sample, which is saying I'm taking one random sample from this population of size 100. I happen to get 35 out of 100, so that's 0.35. Here we can see our population proportion is 0.37, so you can always double check it right there. You could do a few of those if you want, or since we've done quite a few of these, we could go right to 2,000. So I'm a little higher than 2,000, which is fine. Approximate is fine. Okay, so here's our sampling distribution. Looks very similar to how we did it on Rossmann chance. Just the way you find probabilities is a little bit different, okay? We're going to use these tail checkboxes. So we're going to use left tail and right tail, okay? Two tail we'll use later on, not yet. So I need to look at my probability question. Now that I've got this whole thing simulated here, we've got our sampling distribution, and now we wanted to know what's the probability of getting a random sample of 0.42 or higher, okay? StatKey doesn't show us this part, but it is doing that internally, okay? So I'm just going to write the probability statement. Probability that p hat is greater than or equal to, 0.42. Got distracted by some noise outside, so hopefully you can't see that or hear that. Okay, 0.42. Okay, so this is a greater than, which is pointing to the right? That means 0.42 and higher. So we're going to go to the right. So we're going to click on right tail. Okay, now the numbers that come up in these boxes are the default values. So we always need to change these values, almost always. So the number across the bottom, this is the scale for whatever our data set is. So we're in a proportion land, so this is our proportion, right? Proportion in the sample that got had type O positive blood, okay? You can see the mean is right about 0.37. We want to know what happens with the chance of getting 0.42 or higher. So I need to change this bottom box. The top box is the proportion, so it's the proportion of the red X's. So each one is turned red here. So I'm gonna click on the box and enter 0.42. Enter, and you can see it adjusted to 0.42, and the proportion overall, so it's not telling me the fraction, but we could we could figure it out by it's taking a certain number, dividing by 2004 in this case, and it's getting 0.192. Okay, so a little bit different from what we got before. 0.192, we got 0.1625. But remember, these are both simulations, so if we reran this one, we'd likely get a different value. If we reran this one, we'd likely get a different value. Okay, so I'm also going to write right tail right there, so you can remember this or refer to it on your notes. So using the right tail for going to the right, and let's look at the next one, less than 0.25. I bet you can guess we're going to go to the left. And this is an arrow pointing to the left. It's 0.25 and below. So we're going to use the left tail box. I'll go ahead and write out my probability statement. Probability that p hat is less than or equal to 0.25 is equal to what? Or you could use an approximately equal sign there as well. Okay, I'm going to check the left tail. You can check both of these at the same time, and you can enter, if let's say you had a between, you could enter both of these numbers, okay? We don't want to use two-tail for that because with two-tail, the two boxes are tied together, and so if you change one, it'll shift the other, and then you won't be able to get the two numbers you want. But we will use that later on. I'll show you what that's for. So I'm going to just uncheck right tail, so that's these are independent of each other, but just to get that out of the visual space. Okay, so again, default values, these you'll see these always come up as 0.2025. Well, I'd already changed that one. Never mind. So their default is 0.025, 025, and 95 in the middle. Okay, so I need to put in 0.25 here because that's the probability I want to find, and then it's highlighting that and to the left in red, and it's counting those red X's out of the total, and it's getting 0.004 or 0040. Okay, so I'm going to write that down. 004. Okay, again, this will vary from simulation to simulation. Let's double check what we got. So we got 0055, so again, a little bit different. And that's why in MyOpenMath there is a tolerance to allow for that simulation to simulation variation. Okay, great. I hope that helps, and I'll see you in the next video.